All right, guys, so this is going to be the second video for this week. If you've already watched the first video, which I hope that you have, then you know that direct substitution is going to be your first line of attack when you're trying to evaluate limits. It's not always going to work, okay? There's going to be times when you end up getting 0 over 0, which is called the indeterminate form. And the two methods that we're going to look at right now is how to sort of deal with that. So you may have to multiply by the conjugate. You might have to factor. We're going to see right now. Okay, so if you take a look at this particular problem, you can see because of the denominator that direct substitution is not going to work. If I put -1 right here, I get a 0 in the denominator. That's undefined. It doesn't work. I'm going to have to do something else. So if I factor this problem, right, this is a sum of cubes. I warned you that would never go away. Then the problem now looks like this, right? It still has the limit notation. Don't forget this notation. Please don't let it go. We're still approaching -1, but now these cancel out. And so then your problem looks like this, and then direct substitution does work. So the limit is 3 when you do direct substitution. Okay, let's take another one. So this one, again, when you put -2 into this denominator, you can tell it's a 0. It actually ends up being 0 over 0, which is considered, I took my post-it off, it's called the indeterminate form. So we're going to approach this like the last one. I'm going to make this argument, that's what this is called. I'm going to make this argument into something that's equivalent. So if you factor it, right, it's still equivalent. When you go ahead and cancel those out, it now looks like a much simpler problem where direct substitution actually works. So the limit of this particular expression is -3. Okay, let's take a look at this one. All right, and again, you can look just really quick. If you plug 0 into this, we've got a major problem. All right, so what we're going to do instead is we're going to multiply by the conjugate. And I know that you've rationalized denominators before. This in essence is rationalizing the numerator. I'm multiplying the numerator by its conjugate. So then your problem will look like this. Don't forget this notation. Okay, I know I'm probably not going to see you again before the end of the school year, but if I did, and if you missed this, you'd miss this entire problem. And I can guarantee for those of you going on to calculus next year, either with Mrs. Rawson or with somebody else, she will be very picky. Okay, so if I FOIL this, right, this is 2 terms times 2 terms. The first terms give me x plus 1. Outers and inners end up canceling, and the last is -1. And here, if I just sort of leave it in this form for a minute, meaning I'm not going to distribute just yet. This +1 and this -1 cancel out. This x and this x cancel, leaving me with this problem of 1 over the square root of x minus 1 plus 1. And now I can plug in I just realized my problem. That should be a plus. Please forgive me for my mistake. I am not going back and editing it. I'm just going to say it, right? This happens on the board all the time, and I would have gone back and fixed my subtractions to pluses. So anyway, plugging in the 0, here I get the square root of 1, which is 1, plus 1 gives me a denominator of 2, and my numerator is 1. So the limit on this problem is 1/2. All right, continuing. Excuse me. All right, so similarly, I can't plug 0 into this denominator, so I'm going to multiply by the conjugate of the numerator. And this one, I'm just double checking it right now. This one now looks right. Okay, so the next line, when I FOIL, the first term gives me 2 plus x. Inners and outers cancel. The last term is -2. And I'm going to leave this alone, meaning I'm not going to distribute it. This 2 and this -2 cancel out. That x and that x now cancel, so my problem looks better. as 1 over rad 2 plus x plus rad 2. And if I put 0 in, I end up with 1 over 2 rad 2. You don't have to rationalize that. If you do, you end up with rad 2 over 4. Okay, these are two limit things that you will have to memorize. Again, you can pause it, write it down, memorize it, but you will need them. I'm going to set that right up top in case I need to refer to it. Okay, so I'm going to try to do this limit. Again, I can't do direct substitution because a 0 gives me a 0 in the denominator. So here's something that comes in handy. The limit of the product is equal to the product of the limits. Okay, so I'm going to rewrite this argument as something that is equivalent. And the reason I'm doing that is also so I can use this top rule that I just asked you to memorize. This only works if this angle and this denominator are the same. Now, if I'm looking here, those aren't the same. But I can make them the same if I multiply the top and the bottom of this fraction by 7. Right? Denominator times 7, the numerator times 7, and now this piece looks like this. So all I have to do is break this apart using this rule, right? This is a product, right? I'm trying to take the limit of a product. So I'm going to make it into the product of two separate limits. I'm going to have the limit as x approaches 0 of 7 times the limit as x approaches 0 of sine 7x over 7x. Okay, so you remember from the last lesson, if you're taking the limit of a constant, it just equals that constant. And then if I use this rule here, the limit of some angle divided by the same exact number, that equals 1. So the limit of this problem is 7. Okay, let's try another one. Okay, again, I'm going to use that exact same process of the limit of the product is equal to the product of the limits. So let me rewrite this as two separate limits. Okay, the limit of the constant is just the constant. And then this is identical to this. So this just equals 0. And 2 times 0, last time I checked, is 0. All right, and I think this is my last example. All right, so again, I'm going to have to rewrite this. I can't plug in 0 into this denominator, but I can change this into something different. That bell that's ringing is my dog asking to go outside. So my husband is rushing over there to take care of that problem. All right, so if I change tangent into sine over cosine, then I can rewrite this as two separate, right? Because now if you look really close, I do have sine of x over x. It's kind of hidden right there. So I'm going to rewrite this as two separate limits. The limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over the cosine of x. All right, so at this point, you've memorized this part to equal 1. Now I can do direct substitution, right? The cosine at 0 is 1, and 1 over 1 is 1. So the answer to this problem is 1. All right, guys, miss you. I apologize for that one teeny tiny little negative to positive mistake earlier. Hopefully I didn't screw you guys up too bad. Love and miss you. Talk to you soon.